I'm Mark Levels. I'm indeed a sociologist, and I work at the Research Center for Education and the Labor Market, where I lead a program that combines two different sub-programs. And the overall mission of the program is, how do we educate future workers so that they have the right skills for the labor market of the future and the capabilities to use these skills optimally. And so part of the program focuses on the capabilities of workers, and the other focuses on the future of work. Now, as I'm sure you all read newspapers, and you're very much looped into current events, you've all seen headlines like these over the past couple of years, and so have we. Robots will take our jobs. We better plan for it now before it's too late. Questionable, will the robot also take my manufacturing jobs? And headlines like these have also been published for high-skilled white-collar work, for different types of sectors and so forth. Very much unclear how automation and robotization will actually impact the labor market. We know that in 2019, a majority of employers was planning to automate more in the future. This is comes from a 2019 Mercer study that shows that 60% of all companies in Europe planned back then to invest more in automation. And how do they do that then? Well, they prepare their organization in various ways. They redesign jobs. They identify how employees may support or disrupt changes. They revise workforce plans with the idea to close potential skills gaps. That's going to be important later. They adapt skills requirements to new technology. That will also be important later in the context of this talk. They've developed future-focused people strategy. They identify gaps between current and required skill supplies. And 1% of all companies did not do any of the above. So 99% of all companies in Europe is now trying to figure out how the promises that automation harbors can be used to make their businesses more productive and more efficient and more effective. Now, working at an institute that is called the Research Center for Education and the Labor Market, one wonders what the implication of such developments are for the labor market. And this is where various other programs that we will discuss, that I will discuss with you today, come from. And what I want to do is I want to take you a little bit along the journey that we started a couple of years ago, trying to make sense of all of this, share with you some thoughts, some findings of our own, some findings by others, and try and generate a little bit of try to draw some conclusions and try to infer from these conclusions some implications that might be important for you. And I will revisit this specific graph at the end of my presentation to set up the discussions further on during the day. Sorry. We saw that companies are planning to automate more, and they're doing so for a very good reason, because machines are increasingly getting better at stuff. They are better at doing things that normally would be done by humans. We've seen in the scientific literature papers like this, where an AI is capable of beating the best human Go players. Go is a tremendously complex game that requires strategic thinking and cannot be solved by brute force computing like chess can. So there's a very, very elegant solution to the game of Go where you can win. And we have an algorithm that taught itself to learn how to play Go and then beat human chess players. So strategizing is now something, I guess, that computers can do better than humans. There is an AI that can beat, and I'm sure you know all these examples, that can beat the best human poker players at their game. So it knows better how to bluff, how to read bluff, how to calculate pot odds and whatnot. And then there is this paper that was kind of important a couple of years back, where an AI played 47 arcade games and then used what it learned in one game to also win in another game. A thing called transfer learning, which is generally seen as a building block for artificial general intelligence. In our own work that we do at ROA, we also see the consequences of AI. We are together with the OECD working on a research project called PIAC, in which we do numeracy and literacy tests in representative parts of the OECD country population. OECD had an AI also make these tests and found out that the current AI techniques score as well as or better than 89% of adults in OECD countries, which means if you take a step back, that computers can read and write better than 89% of the population, right? That is a strong finding. And then you wonder, what does that mean then for workers? And the answer is, we're not really sure. So we've seen a decline in the labor share of the national income, human workers contributing less and less to human productivity. And some scholars think that this can be related to automation, whereas others do not. There's a point that is still highly contended. We know that in the past, technological advancement always led to increasing productivity for some, but not for others. So if you knew how to wield an axe or how to use a piece of stone to cut leather, you'd be a more productive member of society. And that would come with benefits, higher social status, and whatnot. And if you did not know how to do that, then you were left out. So there is reason to assume that this will also be the case in this particular technological revolution. On the other hand, we also know that people fear this a lot. This is a newspaper headline from 1928, where back then already people started to wonder about what the implications of automation would be, and they would predict a mass technological unemployment that never really materialized. So for this reason, and because we did not really understand what was going on, and as a research institute, we wanted to understand what was going on, we founded the Inequality Consortium to study the large-scale macro-level implications of this. And I'm going to share some of the results, and then I'm going to move back to what this means on the ground. But I think it's nice to frame the discussions that we will have today, or the dialogues that we'll go through today, by putting it into a wider societal context. What do we find? Well, we find that automation will destroy jobs, but that we do not know how many. It's an important finding. Now, before that we delve into the nitty-gritty of it, you should know that various studies find hugely differing things. So it ranges from 8% to 47% of jobs that might be destroyed by automation, a bit dependent on how one models things and how one defines things within these models. In Inequality, we had a little bit of a different approach. We tried to figure out, given current labor market trends that we understand, how will then automation of certain jobs impact these labor markets, given certain reasonable scenarios. And we found that automation will, depending on the scenario, will destroy between 5 or 44% of all jobs, which ranges between 13 million and 107 million jobs in the EU in all sectors. We also found that all these sectors are affected differently. So that's a huge finding. And what we also find is regional differences. So the south of Europe seems to be much more susceptible to automation risks than the north and the west. We also found that automation will create jobs. Large review done by colleagues of ours at ROA, together with researchers at Oxford University, studied the literature on replacement and reinstatement effects of automation, and they show that automation, the way it's studied now, will almost certainly lead to replacement, or has led to replacement, which means that machines will replace humans in certain tasks. But also there is huge support for reinstatement effects, which means that automation will create new jobs that humans can then do. I'll get back to that later, to what that means later. I want to first try and get a little bit closer to how many jobs will then be created. And this is something that we could not do ourselves, but the World Economic Forum did. And they assessed that about 85 million jobs will be destroyed and about 97 million jobs will be created with the current levels of automation. So that's huge. And the net effect will be positive, at least according to the World Economic Forum. Now, the thing here is that these new jobs will require vastly different skills. So there is a growing demand for data analysts, data scientists, big data specialists, digital marketing and strategy specialists, business developers, process automation specialists, and whatnot. digital skills, people with digital skills, and people who know how to think outside of the box. There is a decreasing demand for data typists, administrative and secretarial staff, accountants, factory workers, general and operational managers, mechanics, storage workers, and so forth. So what you see here is, even if the effect, even if the net effect is positive, the requirements for these jobs will be generally, as we see now, will be much different than what we used to see before. So that's the thing. Third finding. Yeah. Not sure what just happened. Automation will also change jobs. And here also, we do not know why. The OECD did a fantastic study on this, showing in different countries how many jobs had a high risk of automation, and then also had a significant risk for change. And what you see here is that in most countries, a large part of the jobs is susceptible to change through the automation. Now, the problem is that we don't really know yet how these jobs change. What we do know is that it will change jobs at the level of tasks. And then the question becomes, which tasks will change and how? And there are a number of theories on scientific theories on the way that technological advancements affect tasks. I want to talk about two very briefly. The skills bias technological change that asserts that it is mostly jobs at the lower end of the skills distribution, so that require not very highly complex skills, that will be susceptible to automation. And then there is a competing theory, if you will, a routine bias technological change that will assert that mostly jobs that are made up of tasks that are mostly routine are also more likely susceptible to automation. That will be important later when I talk a little bit about findings from AI economics that we have now. Well, preliminary findings from AI economics that we have that we can already share with you. This is an old verity here, that in order to be productive, and there is some reason to believe that these canonical theories no longer hold. Eric Bjornolson and McAfee, in their 2014 book, The Second Machine Age, they say that human workers, to be productive in the labor market of the future, can either can use three strategies. They either compete with machines, they develop skills that help them to complement machines, or they develop skills that help them to build machines. And that means, so if you start to think about what does that mean at the level of skills, it means, for example, that if you assume that computers cannot engage in ideation or creativity or discovery, that will be a part of the economic activity that will remain fair game for humans. Same thing for complex communication. So complex communication meaning, sarcasm, or looking somebody in the eyes and understanding that what they say differs from what they actually mean. If you assume that computers cannot learn that, then that means that these types of tasks will remain fair game for humans. Now, the problem is that in very many of these fields, we already see that computers can actually do this, and that they can be active in fields where we for long thought that would be definitely something for humans. This is a painting that you might know that is completely produced by an AI, by studying other paintings and understanding what is art, and then it produced this. And the algorithm it actually signed with the algorithm in the bottom. There's a number of paintings like this. We can discuss whether or not it's art, whether or not it's pretty, whether or not it's meaningful, but at least we can identify something like this as a painting. And there's computers writing poems and whatnot. This is also something. We long thought that to work in care, to work in a medical profession, an understanding of the human condition would be essential, and that robots would not be able to take over there, except for maybe lifting people into beds or whatnot. But here we have a robot that is actually used to keep elderly people company. And why is it successful in that? Because robots also do not have all sorts of negative qualities that humans might have. They don't gossip. They don't laugh at you if you get to put your teeth in and whatnot. Right? So we already see that robots take over parts of the parts of tasks that we long thought would be for humans only. This is Andrew Ng. He used to run Google's AI program, and he said every task that can be that requires a maximum level of thinking for 2 minutes can actually be automated. It's a bit of a different perspective from what we've seen before about routine and non-routine, or skilled or non-skilled, and with huge implications. This is then this Eric Bjornolfsson, and he sat down with a guy called Mitchell to figure out what tasks actually could be done by machine learning, and he developed 8. It requires a task that has a learning function that maps very well-defined inputs to very well-defined outputs. There have to be very large-scale digital data sets with these input-outputs linked, or they can be created. There has to be clear feedback with clearly definable goals and metrics. These are all necessary preconditions for AI taking over tasks. No long changer of logic or common sense reasoning. No need for detailed explanations of how decisions are made. There has to be a tolerance for error, because this AI will produce something with a high degree of probability, and it has to be able to make mistakes here. So, and then this phenomenon should not, that is learned, should not change rapidly over time. And finally, there has to be no specialized dexterity, physical skills, or mobility required, because robots in their current states are still largely unpractical. Advances are made in that field, but it's still very hard for many robots to pick something up before without crushing it. Okay. Yes, was there a question? No, okay. Automation also changes job tasks, but we don't know how, as a second part. So there is 2 ways in which generally automation can help us do tasks. Either it will substitute us completely, or it can augment us. So it can help us do our jobs better. And the problem here is that there are different impacts for different, or the assertion here is that there are different impacts for different types of jobs. So for our job as scientists, a robot will probably, or an AI will probably make us more productive, and it is already doing so. So there is robots here that figured out how to do analysis faster, and how to write papers. Here, science writing can largely be automated. There is an AI that can go through literature, make a systematic review of this literature, and then also write these findings down. That will make our lives much easier, because people spend, people spend a lot of time doing this, and that can be reduced. So that will make us more productive. For other people in other jobs, AI might have a different effect. Here is an example of an orange picking machine. There is a camera in that thing that is also in your kid's your kid's video game console, that scans trees, figures out where the ripe oranges are, calculates the most efficient way to pick these oranges, and then moves to the next tree and does the same thing. Why is that important? It's not trivial, because for the people who still read books, it's a printed collection of paper with letters on them. And know their classics, the Grapes of Wrath. If you remember what the people from Oklahoma did in a Dust Bowl, they went to California to pick oranges. Now, if they do so now, they arrive there, the chances are that there's already a machine doing that. So it'll change also the social dynamic a little bit. All right, that brings me back to this review that we did. Of the 103 studies that focused on replacement, and that shows that that tasks can be substituted, we have to check here. This comes directly from this review. A large number of studies really support this replacement theory, but most of these theories study either software or robots, and that's going to be important later when we talk about the results of AI economics. And also, the second thing that we should learn from this is that most of the studies are done on the meso or the macro level, so regional level, country level, and very few studies actually take place at the workplace. And this is also for the research programs that we did up until a couple of years ago. The biggest problem is that we have a very good understanding of the macro level implications, but not of the micro level implications. We don't know really what's going on the ground. And that's something that we do need to know if we are to understand these consequences. Now, what can we learn from this, from all of this, what I presented up until now, is that for workers, also for employers, but also for workers, automation increases uncertainty. We don't really understand how your job will change. We do really believe that it will change many jobs. We don't know how. Maybe a computer will take over your entire job. Maybe it will help you do your job better. Maybe your job will dumb down because the computer will take care of all sorts of interesting things. Maybe it's the other way around. And your job will become more interesting because the computer will take care of all the knucklehead stuff. We just really, at this point, don't know. And that means that it's super important to zoom in on what is happening on the ground. And this brings me to Marie-Christine Fregin, assuming that she really hates that I put the picture, her picture on here so prominently. But I really do so because she is the one who really thought about this research program and showed us how we can study this in a convincing way. So what she devised a couple of research programs that took us inside of companies to allow us to study what the impact of AI on workers and work are on the ground. So the first study that she devised, we did together with IBM and with Verdi, where we studied the impact of the IBM AI Watson on workers in various firms. And the second is the program that we are here together now for AI economics, which we do together, and I'm very proud of that with IAB and Zukunft 2. What is AI economics? For those who do not know what it is, it's a program in which we do in-company research that we try to co-create with the companies themselves, with works councils, with people working on the floor, with management. I'm going to briefly drink some water. Sorry, thank you. Where we perform insider econometrics analyses on company KPIs that help us assess the effects of AI implementation on productivity of workers. And the idea is that we assess as best as we can the actual causal impact of AI. So we try to devise various research strategies that help us to get closer to measuring the actual impact that AI has without all sorts of forms of bias. Then we're not just interested in does the AI work, but we're also interested in the way that workers perceive the way their environment change, and also whether or not this AI affects their well-being, their job satisfaction, health-related issues, and so forth. And I say we, by the way, I have the honor of addressing you here today, but this is really a team effort. A lot of the colleagues that are involved in this project are here. I don't have time to name everybody, but this is really a team effort in which we try to do this together with, study all these things together with these companies. All right. So how do we assess the causal impact of AI? As I said, we study key performance indicators to measure productivity of workers. And then we come up with an econometric trick that helps us to causally link the AI implementation to these changes in productivity. We also, in various ways, survey workers. And that's not always going the way we intend to. So sometimes it's very hard to survey workers. Sometimes there's the number of workers that we can actually survey is too limited to actually generate statistically relevant results. And then we come up with a different strategy and so forth. So it's very much an ongoing process. But this is the way we do this. And then to get closer to the way that workers experience the implementation of AI and the way they perceive the way this changes their work, we do in-depth interviews with them. And we started with 3 use cases, one logistics firm, one energy firm, and one industry firm here, always in Germany. Now, the first results, and everything here is very preliminary, but it's good that we discuss them still, because I think they're already pretty interesting. One of our PhD students, Pelin Özgül, with various co-authors, both at ROA and at the IAB, studied in a very interesting way, I think, the way that AI is changing German occupation. So what she did is she uses German occupation level data, and then she has a measure of the extent to which these occupations are susceptible to automation. So I think the question is whether or not tasks that are part of these jobs can be automated. And she has a measure that measures routineness of occupation, so the level of routineness, which is part of the German classification of occupations from 1988. There is one digit, the final digit, that says something about how complex a task is. And then she put this together, and then she starts to do interesting things with them. And I'm just going to present very preliminary findings that I hope will convince you that AI is really a bit different from robotics and from software, which, as I just showed you, is what most of the literature is based on. So this is a graph on the extent to which jobs are exposed to AI, robots, or software, and then we distinguish here the level of complexity. And what you see here is that as the skills-biased technological change theory would predict, for robot exposure, that is the blue bar, the more highly skilled you are for doing a job, the lower the chances are that you're exposed to robots. And the same more or less goes, it's a little less pronounced, but the same goes for software exposure. For AI, though, it's the other way around. So the more likely you are, so the more highly complex your job is, and the more highly skilled you are, the more likely it is that you will be confronted with AI. So that is kind of a refutation, if this holds. These are very preliminary findings, but if this holds, this is kind of a refutation of this skills-biased technological change. Also interestingly, routine-biased technological change would predict that machines would be very helpful in doing routine tasks, but not in non-routine tasks. Now, what this figure here shows in the dark blue bars is that for certain non-routine tasks, AI is also very much suited. And jobs that are composed of a high level of analytical non-routine tasks are actually quite susceptible to task automation. So this also seems to be a refutation of this routine-biased technological change. I think it's super interesting, this finding, and I'm very excited about this because it actually shows that the impact that AI will have on the labor market and on workers can actually qualitatively be different from the impact that robots and software had. And it also means that there is a huge new research line needed to really understand what's going on. To summarize, I would say that AI implementation, the way we see it now, can refute skills-biased technological change and routine-biased technological change hypotheses. Interestingly, though, if you are working with AI, a bit in line with what I just suggested with the orange picker and the scientist, the more likely you work, the more strongly you are susceptible to AI, the higher your wages. So it seems to be that AI can boost wages rather than suppress them. And with robots and software, that's the other way around. We don't see aggregate employment effects yet. Now, we also did, the entire team also engaged in qualitative pre-studies. Lara and Avi are very much involved with this. We published a policy brief based on this. So we talked about the effects that AI had on workers by talking to the workers themselves in different roles. And what this taught us is that all the effects that one would expect are not, we don't really see that yet. The results are mixed and also quite, if you permit me, underwhelming. We see some evidence that some workers worry a bit about their jobs. We don't find very pronounced effects on well-being. We find no perceived effects on the way people experience their tasks. And some workers report that they experience some increased productivity, but it's also not very much, not very convincing yet. So more is needed there. And I think one explanation for this might be that we are at the beginning of this development, and that the larger effects might be observable somewhat later down the road. Now, what does this mean then for social partners, for employers, for employees, and for governments? And I think this brings us a little bit back to this bar chart. So if you start to think about what, and I think this is one of the goals for today's meeting, is exactly this, is trying to figure out what this means for you going through these transitions. If you think of the various strategies that you can employ, the question becomes, which is most effective, which helps us best, etc. And a lot of questions can come to mind. If you start redesigning jobs, if you start redesigning skills profiles, if you try to fill skills gaps. And one of the issues here is that any of these strategies has very uncertain outcomes. You don't know what will work. You can't really change a job task if you don't know what the AI will be able to do in the future. You can have ideas about that, but they might not be set in stone. And they might have, and that's also the second point, unintended consequences. I'm going to discuss that a little bit more in a second, but for now, maybe some questions that will help you through this dialogue forum. I think questions that you might address to help you guide your thinking, and by no means this is don't limit yourself to this, but these were questions that I would be asking myself if I would be a worker representative or an employer or a policymaker. What are my strategies for automation? Which of the strategies that I just presented actually do help you? And which one are actually viable in your specific situation? And which ones are you actually employing? And then you might ask yourself, which workers, which jobs, and which roles are affected by the changes that we try to make, and how? What are the intended consequences? And also, very important, what are unintended consequences? And then most importantly, how can you really assess the risk of these consequences? How can you figure out whether or not the consequences that we intend actually materialize, and how can we figure out to avoid unintended consequences, and how likely is it that they will take place? What are the costs involved? And then, of course, finally, how can we mitigate the risks by design? How can you produce an implementation process that can help you mitigate the risks, maximize utility, and mitigate the risk of unintended consequences? And as a primer for a discussion like this, at my institute, we do a lot of research on reskilling, which seems to be a very important strategy for dealing with macro level inefficiencies, but also a very important strategy for retraining part of your workforce, part of the workforce for working under AI. And the findings from this research show really how difficult this can be, and also some of the unintended consequences that you can encounter. So first, you see here that about 55% of all workers, these are Dutch data, by the way, if you'll permit me, but I'm sure similar graphs can be produced for Germany. In the Netherlands, reskilling is really something that is done by the employed, but I argue that it's not the employed that you might want to reach. So the people that might need reskilling most are hardest to reach. So the lower educated workers are, the less likely it is that they engage in reskilling. People in permanent contracts are more likely to engage in reskilling. people in temporary contracts are less likely to engage in reskilling, whereas they might also need it to be, maybe not within the firm where they are now, but they do need it to remain active on the labor market. So there is a difference here in meso-level interest by the firm, micro-level interest of the employer and the employee, and macro-level interest of the society writ large. This is also important. So not very many people are actually engaged in reskilling to prepare for automation. So there's a lot of courses being followed, but not very many of them are tailored towards reskilling for the future of work and the way it changes through the automation. And interestingly, the people who are more at risk of losing their job or seeing their job change through automation, the more at risk they are, the less likely they are engaged in or intending to engage in reskilling activities to prepare for this future. And that is most probably because they don't see the urgency. The more likely it is that people lose their jobs or see their jobs change through the automation, the less likely it is that they believe that that is actually the case. Right? So there seems to be a discrepancy here, or an interesting paradox at least, that we need to solve. And then finally, we might find it very hard to actually reskill a lot of the workers, for the simple reason that not everybody can actually be retrained to utilize the skills that we need them for. This is also from PIAC, the numeracy literacy survey that we hold. The red line, these are numeracy skills by higher educated people, the blue line, middle educated people, and the gray line, lower educated people. There's large overlap, which I guess is very much encouraging. But what you see here is that about 1/3 of all workers have at best rudimentary numeracy skills. And about 8% of all workers have very low skills. And by very low, I mean they are not able to do even very or only able to do very rudimentary things like addition and subtraction and so forth, and nothing more complex than that. So these people will probably not be trained as Python programmers, right? And if Python programmers is what we vastly need, then these people will probably have to be reallocated, and it's not very sure what they'll do. So this adds also to the uncertainty of the workers, but it might also add to the uncertainty of employers, because you have to figure out what to do with people and how to re-educate them, and how to figure out which roles or functions they can fulfill in a company if it's more strongly dominated by digital skills.